Good morning, students. Myself, Vijay Shankar from ECE Department, Chevron Engineering College. Today, we are going to discuss about the analysis of linear systems examples. In the yesterday class, we discussed about some of the examples, and today also we are going to discuss about some more examples on the linear system. So the first example you can see here, the differential equation of a system is given as differential equation of the system is given as d square y of t by dt square plus 5 into dy by dt plus 6 into y of t is equal to minus dx of t by dt. Determine the frequency response and impulse response. Frequency response and the impulse response means you have to find out the h of omega and h of t. Impulse response means the given signal, input signal for the system, linear time invariant system is delta of t. Output response is a h of t. Impulse response h of t and frequency response h of omega. For the given differential equation, d square y of t by dt square plus 5 dy by dt plus 6y of t is equal to minus d by dt of x of t. Okay, my dear students. They are asking to determine the frequency response and the impulse response. Now let us see how we can. So what is the equation? The d square y of t by dt square, 5, 6 and the minus. Take the equation. The example is the linear example. D square y of t by dt square plus 5 d by dt of y of t and minus 6 y of t is equal to d by dt of x of t. Is it right, my dear students? Let's explain, see that whether it is right or wrong. So d square plus 5 and plus 6, my dear students. Here the plus 6 and minus, all the plus only. Plus 6 y of t and minus d by. You have to find out h of omega is equal to. So what is the h of omega and the h of t? Okay. So we know the derivative of d by dt of x of t upon the time differentiation property, the Fourier transformation is j omega into x of omega. And if it is a nth derivative, as I told, nth derivative of x of t, the Fourier transformation is j omega whole power n x of omega. If it is a square, second derivative, the j omega square, third derivative, j omega cube. Using this property, apply here for the linear equation, the differential linear equation or the differential equation. The second derivative means the Fourier transformation is j omega whole square, because we are applying for the y of t signal, y of omega plus 5 into d by dt, the first derivative, j omega into y of omega plus 6 into y of omega. Okay, and that is equal to minus here the d by dt of the first derivative, j omega into, we are applying for the signal x of t, so x of omega. Take the common here, the y of omega, y of omega is y of omega into j omega whole square plus 5j omega plus 6 is equal to minus j omega into x of omega. We know the h of omega is equal to the system transfer function or frequency response. Transfer function means output by the input. Y of omega by the x of omega. So what is the x of omega minus j omega by the total function? So h of omega is equal to minus j omega whole divided by j omega whole square plus 5 j omega plus 6. So first solution is completed. The h of omega is a frequency response. Okay, my dear students. Frequency response. Now I have to find out the second one. What is the second one? Impulse response. So to find the impulse response, so first of all, you can write the factors of the denominator. H of omega is equal to minus j omega whole divided by j omega whole square plus, you write the 5 as 3j omega plus 2j omega. 2j omega plus 6, 2 3 is 6, it is substituted. Minus j omega whole divided by, you take the common here, the j omega, the first two terms, 1, not the 1, 3 plus j omega, and here you take the common of the 2, 3 plus j omega, the 2 3 is 6, and here the 2j omega is equal to minus j omega whole divided by the two factors we got now. One is 3 plus j omega, another one is a 2 plus j omega. Okay, my dear students. I can multiply this function also, the 3 to 6 and 3j omega, 2j omega is nothing but 5j omega, and j omega is a j square. So using the partial differentiation equation, write it as a by 3 plus j omega plus b by 2 plus j omega. Now I can find out the a and the b, apply the inverse Fourier transformation to get the h of t. So 3 plus j omega, you can write it as h of omega is equal to minus j omega whole divided by 3 plus j omega and 2 plus j omega is equal to a by 3 plus j omega plus b by 2 plus j omega. Okay, my students. That is equal to a into 2 plus j omega plus b into 3 plus j omega is equal to minus j omega. So denominator and denominator cancel here. Now compare the functions. J omega coefficients minus 1 is equal to a plus b, and compare the constant coefficients. 0 is equal to a 2a plus 3b, 2a plus 3b. Now you can subtract here. How we get the a is equal to 2a is equal to 2a is equal to minus 3b, a is equal to minus 3 by 2 into b minus students. A is equal to, now substitute this in the first equation, 1 minus 1 is equal to minus 3 by 2 b plus b. Okay. Or directly can substitute the j omega is equal to minus 2. You'll get the B value, J is equal to minus 3, J omega is equal to minus 3, you get the A value. Otherwise, you can do any method. Minus 1 is equal to, take it as a minus 3B plus 2B whole divided by the 2. So minus 2 is equal to minus B. B is equal to 2. Okay, my dear students. So B is equal to 2. So what is the A now? B, we got the 2. A is equal to 2 to get cancelled, minus 3. So A is equal to minus 3. So directly can substitute the J omega is equal to minus 2. Let us take it. Minus 2 means the first term is a 0. Minus of minus is a plus here. 2. 3 minus 2. So B is equal to 2. Is the right answer. And substitute the J omega is equal to minus 3 here. Second term becomes to 0. Minus 3 means A minus J omega. A minus J omega here. The J omega is equal to minus 3 here. We'll get as minus and minus gets cancelled, the A value here. Understood? So let us see whether what we are getting the answer is right or wrong. H of omega is equal to, what is the A? Minus 3 plus J omega plus B as 2 into 2 plus J omega. Now I can multiply here. Minus 6 plus minus 3 J omega and 6 minus 6 plus get cancelled, and 2 J omega minus 3 J omega is a minus J omega. That's the right answer. Okay, my dear students. So H of omega, now we can apply the inverse Fourier transformation. It is in the form of 1 by A plus J omega and 1 by A plus J omega. Apply the inverse Fourier transformation. Apply inverse Fourier transformation. H of t is equal to impulse response. H of t is equal to minus 3 is a constant, and it is in the form of 1 by A plus J omega. E power minus 3t mu of t plus 2 is a constant here, and 2 plus J omega e power minus 2t mu of t. Okay. Impulse response is equal to, is the impulse response. Okay, my dear students, we got the minus 3 e power minus 3t mu of t and 2 into e power minus 2t mu of t. And what we got, it is a frequency response minus J omega by J square plus 5J omega plus 6. Okay, so let us see whether we are getting the same answer or not. What here? See the J by H of omega is equal to minus J omega by J omega whole square plus 5J omega plus 6 frequency response, and the H of t impulse response of the system, the 2 into e power minus t minus 2t mu of t and minus 3 e power minus 3t. Okay, what we got the same answer. Next one, you can see the my dear friends. Second example, the input voltage to the RC circuit. The input voltage to the RC circuit is given by S of t is equal to t into e power minus t by the RC mu of t, and impulse response means nothing but H of t, my dear students. Impulse response of the circuit is given by the H of t is equal to 1 by RC e power minus t by RC mu of t. Find out the output. Given the X of t and H of t, you have to find out the output function. Okay, there is no any relation between of y of t is equal to, only we have the system function H of omega is equal to y of omega by x of omega. Okay, and what is the y of omega is equal to H of omega into x of omega. To find out the y of t, the output signal y of t, inverse Fourier transformation, h of omega, x of omega means h of t is a convolution with x of t. The two signals is given, you can apply either it is a convolution or otherwise find out the Fourier transformation of x of t given, find out the Fourier transformation of h of t, and take the ratio between of, not the ratio, the multiplication factor of h of omega and the h of x of omega and h of omega. Then you can find the, or you can apply the inverse Fourier transformation of that function. Following my dear students. Now let us see how solve this example. X of t is equal to t into e power minus t by rc mu of t, and is a 1 by rc e power minus t by rc into mu of t. Okay. The first one is a t. Second example, the given x of t is equal to t into e power minus t by rc mu of t, and h of t is given 1 by rc e power minus t by rc mu of t. I have to find out the y of t is equal. So what is the y of t? Okay, my dear students. Now, first of all, first take the x of t signal and apply the inverse Fourier transformation x of omega is equal to, for the given x of t, the integral minus infinite to infinite x of t e power minus j omega t dt, and that is equal to, what is x of t, the integral minus infinite to infinite t into e power minus t by rc mu of t as x of t and e power minus j omega t dt, and change the limitations as 0 to infinite. Otherwise, directly you can find out the Fourier transformation e power minus t by rc mu of t, e power minus at mu of t. What is the e power minus at mu of t Fourier transformation is? Using the formula, you can solve to get the x of omega. Otherwise, you can use the properties. The Fourier transformation of e power minus at mu of t is 1 by a plus j omega. If it is multiplied with the t, e power minus at mu of t Fourier transformation is 1 by a plus j omega whole square. Use these two equations for the x of t. X of omega is equal to, instead of a, 1 by rc is there. 1 by a is a 1 by rc plus j omega, and it is multiplied with the t, so you have to take the square of that function. So x of omega is equal to, take the LCM, rc square whole divided by 1 plus j omega rc whole square. As x of omega we got. What is the h of t with the same function? H of omega is equal to e power minus t by rc into mu of t. According to that, it is also 1 by rc plus j omega. There is no any t is here, but it is multiplied with the 1 by rc. Okay, so into 1 by rc also. Take the x of omega is equal to, take here also the LCM, you'll get in the numerator rc plus 1 plus j omega rc into 1 by rc. So rc get cancelled, it is 1 by j omega rc, and x of omega is equal to rc square by 1 plus j omega rc whole square. Why it is a square? Here it is a given, it is a x of t is a t into. Now to find the y of omega is equal to h of omega into x of omega. According to the frequency response or the system transfer function. H of omega 1 by 1 plus j omega RC, and x of omega is RC square whole divided by 1 plus j omega RC whole square. So now to simplify, the y of omega is equal to RC whole square divided by 1 plus j omega RC whole cube. Okay, my dear students. So RC is a constant. So y of omega is equal to RC whole square into 1 by 1 plus j omega RC whole cube. Now you can rewrite this function as RC whole square. Take the RC is a common here. 1 by RC you can take as a common 1 by RC plus j omega whole cube. Okay, my dear friends. It is 1 by r cube is equal to RC whole divided by RC whole cube, RC square, my dear students, here RC square and RC whole cube into 1 by RC plus j omega whole cube. Now r square is get cancelled 1 by RC. So y of omega is equal to 1 by RC whole multiplied with 1 by RC plus j omega whole cube. We know the y of e power minus at mu of t Fourier transformation is 1 by a plus j omega. The t into e power minus at mu of t. The Fourier transformation is a 1 by a plus j omega whole square. Okay, j omega whole square. If it is a t square e power minus at mu of t, what is a Fourier transformation? Again, it is another way, the 1 plus j omega whole cube multiply with the a plus j omega. Now the above equation is in the 1 by a plus j omega whole cube. So inverse Fourier transformation, you can apply the inverse Fourier transformation. Apply inverse Fourier transformation to y of omega. Y of omega becomes of y of t is equal to, here the constant 1 by RC and 1 by a plus j omega whole cube. It is according to this function, the t cube into e power minus a. Instead of a, the value is a minus 1 by RC into t mu of t. So we got the y of t is equal to, the output y of t is equal to 1 by RC t cube into e power minus 1 by RC into t mu of t. Okay, my dear students. So see here. Given the x of t, the t into e power minus t by rc into mu of t, and impulse response h of t is 1 by rc into e power minus t by rc. And we apply the Fourier transformation of the two functions. X of omega is equal to, the Fourier transformation of the function is rc square into 1 plus j omega rc whole square. And the y of h of omega is equal to 1 by 1 plus j omega rc. You can multiply the two functions rc square by 1 plus j omega rc whole cube. Okay, my dear students. So take the rc as a common here, rc as a common, rc square and rc cube. See here there is a missing term is there, my dear students. 1 by rc plus j omega whole cube. Okay, my dear students, this is a inverse Fourier transformation. You note it down this one. After also, we'll send to this is a material. You have to change this value, my dear students. Whenever you have listen, then only you can know what is the missing terms in the materials. rc square is there in the numerator. I take the common of rc whole cube, 1 by rc plus j omega whole cube. Now 1 by rc is there, 1 by rc, and according to the t into e power minus at mu of t, 1 by a plus j omega whole square. If it is a t square e power minus at mu of t, 1 by a plus j omega whole square. Actually, it's not the t square, my dear students. It's a t square by 2. T square by 2 e power minus at mu of t. The Fourier transformation is, because it's 2 factorial, 1 by 1 plus, not the 1 plus, a plus j omega whole cube. Okay, then after it is a t cube. If it is a 4, a plus j omega 4 means t cube by 6. Nothing but the 3 factorial. Okay, previously it is a 1 factorial and it is a 2 factorial, 3 factorial. 3 factorial means 3 into 2 is a 6. Okay, t cube by 3 factorial. It is a 2 factorial, my dear students. E power minus at mu of t. The Fourier transformation is 1 by a plus j omega power 4. Here cube means here you will get the 4. Here the square means here the 3. Here the 1. T power 1 by 1 factorial. 1 factorial means 1 only. The 2 factorial is also 2. But the 3 factorial is a difference. 3 into 2 into 1. So 6. And so on. So actually the t power n by n factorial e power minus at mu of t. The Fourier transformation is 1 by a plus j omega whole power. Here the n means is a more than n plus 1. N plus 1. These are actually the Fourier transformation of the given function. So see here the 1 by rc t square by 2 e power minus t by rc into mu of t. Whatever we got, the y of t is equal to. Understood, my understood. See, that only the same thing, but we missed the 2 there. The 2 factorial. 1 by the t square by 2. So 1 by 2 is also there. 1 by 2 rc t cube. The t square, my dear students, it is not the t cube. Here also I did wrong. It's a t square. T square 1 by rc t square by 2 e power minus 1 by rc into t mu of t. Okay, my dear students. You take this missing term is also you have to note down. Then next problem. You go for the next problem. The x of t is given e power minus 5 the magnitude of t. it is satisfied for the stability function, the integral minus infinite to infinite h of t dt is equal to, what is the h of t given? H of t is a given, this is a h minus h of t is e power minus 5 magnitude of t. Substitute here and dt, integral minus infinite to infinite, integral minus infinite to infinite, e power minus 5 into magnitude of t is equal to integral minus infinite to infinite, e power minus magnitude. If I change this magnitude as t is a negative values, it becomes of positive exponential. T is the positive values, the exponential is a negative. T is a negative values. The negative values means minus infinite to 0. Minus infinite to 0, the value is e power 5 into t. And for the positive values of the t, 0 to infinite, the e power minus 5t, exponential, negative exponential. Apply here and find out. Let us see, we'll explain clearly. The next one, given the h of t is equal to e power minus 5, the magnitude of the t. Magnitude of the t. Okay. How to find out whether it is a stable function or not. Stable system, not the functions, it's stable system. Find whether it is a stable or not. Find whether it is stable or not. Stable system or not. So for stability function, for stability, the condition is integral minus infinite to infinite h of t dt is less than infinite. If it satisfies this condition, it is a stable system. Okay, my dear student, it is a stable system. So the given h of t is e power minus 5 the magnitude of t into dt. Whether it is a less than the infinite or not, we have to find out. I am taking the negative values of t, integral 0, not the 0, minus infinite to 0, e power negative values. Negative values means positive exponential, e power 5t dt plus, and for the positive values, 0 to infinite. So actually this is a 0 plus and this is a 0 minus, my dear friends. Just below the 0 and just above the 0 here. Both are the zeros only, the 0 minus and the 0 plus. Don't confuse here. Either it is a 0 minus or the 0 plus, both are the same. E power, now it is a negative value, minus 5 into t dt is equal to, now apply the integral for the 5t, e power 5t by 5, 0 and minus infinite plus e power minus 5t by minus 5 with the infinite and the 0. Now here the upper limit is a 0, e power 0 is a 1, and the lower limit is infinite, becomes of the 0. 1 minus 0 by 5 plus, and upper limit is infinite here. So 0 minus lower limit is a 0, e power 0 is a 1 by minus 5. Okay, my dear student. Here the 1 by 5 and here also the 1 by 5. Minus minus get cancelled, 1 by 5. So h of t is equal to, not the h of t, the stability function, plus 1 by 5. So 2 by 5. The total is the 2 by 5. It is less than infinity. 2 by 5 means it's a finite value. Finite value. Therefore, the given h of t is a stable system. H of t is a stable system. Okay, my dear students, because the value what we got for the stability condition is less than the infinite. Because of the 2 by 5, the value is a finite value. Understood? So the 2 by 5 is a constant. So the system is stable or the stable system. And second one, we can see the h of t is equal to given e power 4t into mu of t. 4t into mu of t. So apply here in the condition, for the stability condition, integral minus infinite to infinite h of t dt is less than the infinite. E power 4t into mu of t dt. E power 4t into mu of t dt. And integral minus infinite to infinite, substitute here the mu of t as a 1, becomes of 0 to infinite, e power 4t into t. E power 4t into dt. Apply the integral for the exponential value, e power 4t by 4. Upper limit is infinite and lower limit is a 0. E power infinite is a 1, not the 1, 0. Minus e power 0 is a 1, minus 4. So minus 1 by 4 is also a constant. Is also a constant of infinite. This e power infinite is a 0, my dear students. 0 minus 1 by 4 is also the stable system. Okay, it is not equal to the infinite, my dear students. They're saying it is not the equal to the infinite. How it is the infinite? Is the magnitude is e power infinite is a 0, my dear students. They wrote it is a infinite. Okay, it is wrong. E power infinite. You see the e power infinite is a 0. 0 by 4 minus 1 by 4. What is a 0 by 4 is a 0, minus 1 by 4 is a minus 1 by 4. Is less than the infinite only. So less than infinite means a stable system. Okay, stable. Don't write it is a 0 here, and it is a minus 1 by 4. It's not unstable, my dear students. It is a stable system. Stable system. Understood? Now e power minus h of t is equal to e power minus 4 into t. So here the magnitude, whenever if you can take it is a magnitude values, in that the magnitude values also it is a minus infinite to the 0. Minus infinite to the 0. Okay. E power minus 4 into t mu of t is a stable function. Okay. And coming to the 4, what I am taking the magnitude of this one, the magnitude here, it is a e power minus 40 or the e power plus 40. Whatever the same here, minus 4, the magnitude of t, and here the minus 40 and the plus 40. So both are the stable functions. And h of t is equal to t cos t mu of t. T cos t mu of t. And h of t is equal to e power minus t sin t mu of t. Is a stable or unstable? Okay. T into cos t. T into cos t, you can apply here as a by parts. As a by parts. By parts is so t into, so first of all you can t and apply the integral of cos t dt minus the integral of the derivative of t is 1, and again the integral of cos is a sin t dt, and apply the integrals of 0 to infinite. Why it is a 0 to infinite? Because of the mu of t here. Okay, so t into sin t minus, again it is a integral sin t, minus cos t is a plus cos t. Apply the integral is a infinite and the 0. So definitely it becomes of infinite only. The function is infinite, my dear students. So t into sin t, the t value is infinite here. You got to substitute the t value as infinite. Definitely infinite plus anything is infinite. Infinite into anything is infinite. So is equal to the infinite. Then the system is unstable system. System is unstable system. And coming to the e power minus t sin t mu of t. E power minus t sin t, e power ax sin bx. Using that formula, you can apply the integral, my dear students. Definitely you get the stable system. E power minus ax sin bx. E power ax by x square plus bx into a cos x cos bx plus b sin bx. Using that formula, you can find out and the stable function. Understood, my dear students? To the next one. The system produces the output of y of t. Output of y of t is e power minus t mu of t. And for an input of x of t is equal to, e power minus 2t mu of t, e power minus 2t mu of t. Determine the impulse response. Impulse response means h of t. And the frequency response h of omega for the given functions y of t and x of t. Y of t is e power minus t mu of t, and x of t is e power minus 2t mu of t. Now I will explain here. Y is e power minus t. Another example. Given the y of t is equal to e power minus t mu of t, and x of t is given e power minus 2t mu of t. You have to find out the impulse response h of t and frequency response h of omega is equal to. Okay. So what is the y of t? What is the y of t is e power minus t mu of t. Now we can apply the Fourier transformation. Y of omega is equal to e power minus t mu of t, e power minus a t mu of t. A is a 1 here, 1 plus j omega. Y of omega is equal to. What is the x of omega? A is a 2. So 1 by 2 plus j omega. We need the h of omega. H of omega is equal to y of omega by the x of omega, because it is system transfer function also. Frequency response, or it also call it as a system transfer function. Y of omega by x of omega. What is the y of omega? We got 1 by 1 plus j omega whole divided by 1 by 2 plus j omega. And that is equal to, we get the numerator in the 2 plus j omega by 1 plus j omega. So modify this as a 2 as a 1 plus j omega whole divided by 1 plus j omega. Okay. So h of omega is equal to 1 by 1 plus j omega, 1 by 1 plus j omega plus 1 plus j omega by 1 plus j omega is a 1. Okay. The frequency response or the system response h of omega is equal to, we got 2 plus j omega by 1 plus j omega, or 1 plus 1 by 1 plus j omega. We need the h of t also. Is a frequency response. Frequency response or the system response. We need impulse response also. Impulse response is h of t. So inverse Fourier transformation of this function. What is the inverse Fourier transformation of 1 by 1 plus j omega e power minus t mu of t plus 1. What is the 1 inverse Fourier transformation? Is a delta of t. But 1 Fourier transformation is 2 pi delta of omega. So h of t is equal to impulse response. It is impulse response. Okay, my dear students. H of omega, we got the 2 plus j omega by 1 plus j omega, and h of t is a e power minus t mu of t delta of t. Okay. Now you can see whether we are getting the same answer. H of t, impulse response, delta of t e power minus t mu of t, and h of omega is 1 plus 1 by 1 plus j omega. Got it, my dear students? The next one. See, the transfer function of the low pass filter is given by, the transfer function of a low pass filter is given by h of omega is equal to 1 plus k into cos omega t e power minus j omega t, 1 plus k cos omega t e power minus j omega t, where the omega is less than the 2 pi into b and 0 for greater than the 2 pi into b. Determine the output response or the output y of t when a pulse x of t band limited in b. X of t is a band limited to the minus b to the b minus 1 is applied at the input. So we know the y of omega is equal to x of omega and h of omega. Nothing but h of omega is output by the input. X of omega, the given h of omega you can substitute here 1 plus k cos omega t e power minus j omega tau. Or you can take the small t also. Okay, this is a small t and this is a capital T, my students. So x of omega into e power minus j omega tau plus k into x of omega cos omega t into e power minus j omega tau. Okay, we know x of t minus tau plus x of t plus tau, the Fourier transformation is 2x of omega into cos omega t. Okay, x of t minus tau is x of omega into e power minus j omega tau. Okay, why it is a tau? The t minus tau, the shifting property, according to the shifting property, what saying the x of t minus t naught, the Fourier transformation is e power minus j omega into t naught minus t naught into x of omega. So what is the instead of t naught here? The t is there. Okay, so the tau, not the t, is a tau, my dear students. So x of t minus tau, the Fourier transformation is e power minus j omega tau x of omega. Okay, it is a Fourier transformation of the function x of t minus tau, x of omega into, if it is an inverse Fourier transformation, you will get the x of t minus tau. And coming to this function, 2 into x of omega cos omega tau. 2 into x of omega cos omega tau. It is x of t minus tau plus x of t plus tau. How it is the cos function, you can write as in terms of the exponential values. Exponential value. Okay, I will explain this as in the function x of t minus tau. What is x of t minus tau? E power minus j omega tau x of omega. The Fourier transformation, my dear students. Fourier transformation. What is a cos function in terms of exponential value? 2 into x of omega into cos omega tau. Cos omega tau is e power j omega tau plus e power minus j omega tau by 2. Okay, my dear students. 2 to get cancelled here. It is in the form of x of omega into e power j omega tau plus x of omega into e power minus j omega tau. See here the x of omega e power minus j omega, this is a function. We'll call it as x of t minus tau, inverse Fourier transformation. And now here x of omega is a plus. So x of t plus tau. T plus tau, the minus of minus tau. So x of t minus tau, x of t plus tau for the function is 2x of omega cos omega. 2x of omega cos omega tau. Follow my dear friends. Using these two Fourier transformations, the given function y of omega is equal to, after multiplying x of omega e power minus j omega and x of omega cos omega here, see, 2 into x of omega cos omega tau only, my dear students. There is a e power minus tau also. cos omega t is a cos omega t, not the tau, it is a t. This is a tau. Okay, if it is a t means this value is also the t, cos x of t minus t, x of t plus t. Now the y of t, apply the inverse Fourier transformation of this function. Y of t is equal to f inverse of y of omega, f inverse of x of omega e power minus j omega tau plus k into x of omega e power minus j omega tau cos omega t minus 20. This is a t. So what is the inverse Fourier transformation of the first function? X of omega e power minus j omega tau is x of t minus tau. Okay, t minus tau. This is a tau, my students. And then second one is a k value is already there. The k is a constant. And if it is a 2 into x of cos omega tau only, k by the 2, you can multiply the 2 here, the x of t minus tau minus t. Why? Here again it is multiplied with the e power minus j omega tau, my students. So for that function, t minus t is already there, and you can shift with the tau samples, the total function. This is a total function x of omega, and it is multiplied with the e power minus, means this function is shifted with the tau samples. Okay, my dear student. X of t plus capital T, and it's a minus tau. This is a minus tau, my dear student. It's minus tau. Following. Once again, I will explain the k into x of omega cos omega tau, not the omega tau, omega t, my dear students. And this is a 2 is also multiplied. For 2 multiplication, I take it as a k by 2. For this only, we got x of t minus t plus x of t plus t. But it is multiplied with e power minus j omega tau. And any function, the frequency domain function is multiplied with e power minus j omega tau. The shifting is occurs. What is the shifting? X of t minus t naught is already the shifting is there. Now it is a minus tau. Following, my dear students. So for this, x of t minus tau, and x of t plus t minus tau. Now I can simplify this function. Y of t is equal to x of t, the delayed function y of t is equal to, you see the function is k by 2, x of t minus tau, not the t minus tau, my dear students, t minus t, and x of t plus t with the delay of delayed by the tau. Why I am taking this only the function? See all the terms here, the x of t minus tau, x of t minus tau with the tau, and x of t plus tau. All the 3 terms is delayed by the tau. So I written as a y of t is equal to x of t plus k by t, and tau also removed here, the x of t minus t plus x of t plus t, and the delayed by the tau function. Okay, so the output y of t, when the pulse x of t is band limited to the 2b is applied at the input, we got the output function is x of t plus k by 2, the x of t minus t plus x of t plus capital T. Following. This is small modifications, my dear students. So you can note down this one. This is not the tau, this is a capital T. This is a tau. And here also these two are not taus, capital T and the capital T. And here it is not the capital T, it is a tau, my dear students. So all the 3 terms is delayed with the tau samples. So x of t I wrote here, x of t plus minus t, capital T, and x of t plus capital T is delayed by the tau samples. Okay, my dear students. Now coming to the next one. So determine the maximum bandwidth of the signals. Determine the maximum bandwidth of the signals that can be transmitted through low pass RC filter. Low pass RC filter as shown in the figure below. If over this bandwidth, the gain variation is to be 10% and the phase variation is to be within the 7% of ideal characteristics. You have to find out the maximum bandwidth of the signal. Maximum bandwidth of the signal, my students. So here, given the network, RC network, the low pass RC filter. Okay, my students. R and the C, the 20 kilohertz and the 10 nanofarads with the input and the output across the 20 kilo ohms. RC network is transferred into the S domain representation. S domain representation. Vi of S, R, and C we can written as a 1 by C into S. See how it is converted into the S means definitely if it is a low pass Laplace transformation you can understood. Otherwise simply have to remember this one capacitor you can write as 1 by C into S and the resistance output is a V naught of S. H of S is equal to V naught of S by the Vi of S. Output by the input is nothing but the transfer function, my students. Transfer function. What is a V naught of S? Parallel of the resistance and the capacitance, or is parallel with 1 by C into S. And Vi of S. Vi of S means I into R plus 1 by the C. Is a addition of R with the parallel of 1 by C plus R function. Okay. R parallel R by CS in by the R plus 1 by CS and R by CS by 1 plus R by CS plus R. Simplify this equation. H of S is equal to 1 by 2 plus SCR. Okay, my dear students. So R parallel means 1 by R plus 1 by CS. 1 by R plus 1 by CS. Simply we can simplify that function as of 1 by R plus 1 by CS is a take the common R into R by 1 plus SCR and R by 1 plus CR plus R. Again take the R is a common term. Remaining the H of S is equal to 1 by 2 plus SCR. But the given R is equal to 20 kilo ohms and C is equal to 10 nanofarads. Substitute that function. Both the resistance here the 20 kilo ohms only, my students. H of S is equal to, after substituting the values of 20 and 10, H of S is given as 500 by S plus J ohm, S plus the 1000. Put S is equal to J omega now. S is equal to J omega. We'll get as H of omega is equal to 5000 by J omega into 10,000. H of omega is equal to magnitude if I am taking the magnitude of that one. 5000 by the under root of omega square plus 10,000. How we got this function? You can rationalize it to find out the magnitude and the phase. Magnitude and the phase means 500 into J omega minus 10,000 by the J omega minus 10,000. Okay, simplify that one. Then you'll get the magnitude 5000 by under root of omega square plus 10,000 and the phi is a tan inverse omega by 10,000. Okay, my dear students. But they're asking that, but there is a 10% variation in gain over the bandwidth B. At omega is equal to 0, the magnitude of H of omega is a 0.5. But there is a 10% variation in gain over the bandwidth of the B. So H of omega is a 0.5 minus 0.5 into 10%. There is a 10% variation in the total function. You have to subtract the 10% variation in the total value, 0.5 minus, I take the 10% of 0.5. Totally you get the 0.45. Okay. So the magnitude of H of omega is equal to, by substituting the omega is a B square plus simplify that one, B square into 10 to the power of B is equal to B is equal to 4.84 kilohertz. But B is nothing but the omega. So varies from minus omega to the omega. 2 pi f. F is equal to B by the 2 omega. And the B, we already got the 4.84 into the power of 3 as a kilohertz here by 2 pi. And we got the frequency is a 770.8 hertz. Phase at the frequency is 770.8 hertz, my dear students. Now the phase angle by substituting the omega is equal to, what is the omega? 4.84. Omega is equal to 2 pi f, my dear students. So omega is nothing but here the B. 4.84 we'll get as minus 25.83 percentage. Minus 25.83 percentage. Understood? So like that we can find out any function if we given in the network is simplified. But here is a very important, my dear students. So V naught of S is these two are the parallel, and the Vi of S is you can apply the network here. R and C and the plus R also. The Vi of S plus R, this one. These two are the parallel, and then you can add the series, the function R. These two are the parallel here, R plus 1 by CS, and it is in the connector of the series as the input function plus R also. Simplify, applying the parallel connection and apply the parallel connection here, we'll get the H of S is equal to 1 by something. Substitute the given values, and S is nothing but J omega. Actually, the S is in the Laplace transformation saying that the sigma plus J omega, my dear students. Sigma is a real function. There is no any point on the real axis. We'll get the S is equal to J omega 1. Means H of J omega. The shortcut notation is the H of omega 1, the frequency. Okay. S is also the frequency, but it is in the form of sigma plus J omega, the real term and the imaginary term also. So put the S is equal to J omega in this function, becomes of 5000 by J omega into 10,000. J omega plus 10,000, students. Okay, rationalize the function. You'll get the magnitude and the phase. At 10% variation of the gain bandwidth, find the H of omega is a 0.45. And from that, you can find the bandwidth band limited of B, omega is equal to, and find the phase frequency F also. Okay. So with this, the completion of all the examples in the analysis of the linear system also. Okay. So this is the completion of the third unit for the EC students, and for the triple half part of the fourth unit is complete. Okay, my dear students. Any doubts? Please raise. Okay. Thank you.